So I've opened up the example spreadsheet. This is what you'll be using for the class assignment. So let's take a look at our data and get oriented. We have the year. There are 4 years here. Year 1, 2, 3, and 4. Quarters. There's 4 quarters per year. Period. When you're doing any kind of forecasting, your periods have to be equidistant from one another. So in this case, we just have them numerically set out 1 to 16. Yeah, they just have to be equidistant from one another so that they're iterative in a way that makes sense that can be picked up by the function. And then we have sales. So this is our sales data. It's very simple. It's very small, easily handleable. So what we want to do is we want to do some forecasting. We'll do it this way first. I want to forecast for a few dates. I want to forecast for like 5 more periods. So like 17 to 21. This is what I want to forecast. I'm actually going to highlight this area because this is the area I'm forecasting. I want it to be yellow's kind of a lot. Green's a little dark. That's kind of ugly. Let's make it... I'll make it that color. It's not the prettiest green, but it'll do. So what do we have here? So this will be year 5 for the first 4, and then year 6 for the last one. Similarly, this is going to be 1, 2, 3, 4, and then 1 there. So we're going to forecast inside of here. This is the area where we'll do our forecasting. What we're going to do is we're going to use a forecast function using exponential smoothing. And it's pretty easy to do. You just have to know what the function is. So pop this open, zoom in. In fact, I'm going to zoom in a bit so that you can definitely see what I'm typing in. And I'll show you what we're looking at. So this is equals forecast.ets. So this first one that we're going to use. If you are positive that there is a linear relationship between time and your data, then you can use forecast linear. We're doing this one because it's easier and makes more sense for our data. So forecast ETS, the target date. The target date is going to be that date right there, comma. The values. The values are the historical values that we have. We're going to use those. I'm going to come back to revisit this, but I'll explain what I'm doing here in a second when I make one valuable change that makes the rest of these a lot easier. So we're going to pick the historical values. So all of those historical values are the ones we didn't make up. These are the ones in this area that we are making up. Comma. The timeline, so that is all these periods. It needs to be in the same date function, as your target date. So our target date's 17. So our timeline is 1 through 16. We wouldn't want to use these because they don't iterate in the same way that 17 would. Be weird. Wouldn't work well. And then seasonality. In this case, seasonality is an object in this function that what we're going to do is you can basically put 1 or 0 in here. We're going to put 1 because we want it to pick up any seasonality that may exist in this. And I'm 100% positive there's seasonality in this data set. So I'm going to put 1 so it picks up any seasonality. We don't need to do these other ones, data completion. Even seasonality is optional. So I'm going to close my bracket, hit go, and it gets me this number. I could make it fall in line with this. I could make it a number and give it a single decimal place to make it fall in line with this, in which case it would be 7.3. Let me revisit this really quickly because I want to do this for the rest of them too. I can manually plug each one of them in. In fact, if I did that, I'm going to start doing that, and I'll show you what that looks like. If I did that, then of course I would choose 18 for our target date, but the values would be the same, and the timeline would be the same, and seasonality would be the same. So if I'm going to do this in a way that is quick, then I can go up in here and I can make some of these absolute. I could make our values absolute because those aren't going to change. If you're on a PC, you can just hit F4. That makes those values absolute, and I can make those for the timeline as well because those aren't going to change either. Okay? Then I should be able to bring that down, and it should calculate all of my other values. And we can check those. Yes, it hasn't changed. It only changes the target date value will change, but the data is not going to change for us. And so we get predictions for all of the following dates. So we need to also put in confidence intervals, 95% confidence intervals, so that we can see, because this is just a point estimate. These are just point estimates for each one of these values. We also want to see the 95% confidence interval for these values. So we can know for certain where this falls between, what this falls between. And so what we're going to do there is we're going to calculate a couple of things. We're going to calculate the margin of error, the lower bound of the confidence interval, and the upper bound of the confidence interval. And these two things together up here are going to be the 95% confidence interval. So how do we do that? Well, there's thankfully a function in forecasting that gives us that. So we'll go ahead and start putting in a new forecast. This second one right here, forecast.ets.confident is the confidence interval. So we're going to use that one. Target date. Target date is going to be the same target date that's over here. Values. The values are going to be the same ones that we have there. The timeline, the same one that we used before. So everything is the same here. It is just the only thing that we're thinking about now is creating the margin of error for it, or calculating the margin of error for it. And then our confidence level is going to be 95. Again, I'm going to go in here and I'm going to make these things absolute, so it makes it easier to calculate this for the other margins of error. Ooh, what did I like? Didn't like something. Oh, I forgot to put in, should be 0.95. Really, it should be 0.95. That should be my confidence level. So let's try that one. There we go. That's much better. So here I have, if we look back at this, we have target date, C18, the absolute values for our values, absolute values for our values, the absolute values for our time series here, and then 95%. That gives us our margin of error. Now let's calculate our upper and lower bound. This one's pretty simple. This one just equals our point estimate minus the lower bound, point estimate minus our margin of error, and this one equals the opposite, our point estimate plus our margin of error. That's that. And what I can do is I can just highlight all those, pull them down, and I get my values for each one of these. So this is my 95% confidence interval. This is what I have for each one of those. This is my margin of error. If I double check to make sure that all those calculations are right, they are right. And then this is just simple addition, subtraction of our margin of error from or to our point estimate that was created by this forecast. So let's go ahead and make this easier to read. Now that we understand these, we can be a little more selective about how many decimals we're using. So I want to go down to 1 decimal, just so it fits in line with all these other things. And gives us an easier time of actually writing out what this means. So let's actually give a response to what all this means together. So if I were to write this out, which you should do for each one of these things, I would say the following. So here I would say we can be 95% confident that sales in thousands, remember, will be between, let's see, what is it, 7.3 and 8.5 during the period 21, I'll say during period 21, which is year 6, quarter 1. That's an explanation of this entire row. So the last thing that we have to do is to calculate error. And I'm going to stick it up here close to the top. The reason we calculate error is so that we can actually tell basically how good a model is. And in our homework that's going to come later, we're going to look at different models. In this case, we're just doing exponential smoothing, which is an easy one. But our homework that's going to come later, we're going to use different models, and in which case we'll need to calculate error to determine which model is better. Now, there's a few statistics that we can use for this. I'm going to calculate 2 of them. I have preference for one over another, but I'm going to calculate 2 of them. We're just going to see if there's any difference, and we're going to talk just a tiny, tiny, tiny little bit about them. And then I'm going to send you on your way to basically recreate this and submit it. So, again, we're going to look at our forecast, if I can spell forecast, and we're going to use this one right here, forecast.ets.stat. That's what we're going to use. So, in this thing, I'm actually going to come up here and do it up here. In this case, we're going to use these values. I don't have to put any absolutes in there because we're only going to do it like once. So I pull my values. It's going to ask for my values. I want those. It's going to ask for my timeline. I'm going to pull that as well. And it's going to ask for my statistic type. So first I'm going to pull statistic number 7, the RMSE. This is the root mean squared error. This is a very standard error that we pull. We generally pull, I'm going to pull 7 and I'm going to pull 6. 6 is the mean absolute error, and 7 is the root mean squared error. Mostly in statistics, we use the mean absolute error. We use the root mean squared error specifically in those circumstances where we want to minimize, or where very large error is undesirable. That probably doesn't mean anything to you, nor should it necessarily. But I'm going to calculate both. We're going to see that they're different. We're just I may talk about at a later date the difference between these two things. But we're just going to calculate both. We're going to see that they're different. So I'm going to pull 7 for that one. This will be root mean square error. Put that there, and I'm actually going to put RMSE so I know that. So what does this mean? Well, nothing at the moment because we're not testing against any different models. We've only done the single model. But when we are testing against other models, we're trying to find the one with the lowest error. I'm going to do the same thing just to do mean absolute error to see if those are different. But this is mostly an effort in just showing you that there are multiple ways to do things, and there are good reasons to know how to do. Whoops, wish I had. There we go. Yes, that's the same. So they're just calculated different ways. The root mean square error basically takes the root at one point in the calculation. But we can get into that at a later date. They're just 2 different types of error. I may calculate different types of error in the homework. But until then, just go ahead and recreate this. Why don't you go ahead and put both of these in? That'll show you how to do both of them. But this is what I want it to look like. So add this. Make sure to have this. Calculate these, of course. Put in an explanation for one of these. In the homework, you're likely going to have to do explanations for each one of them. But in this case, just put this last one in here and make sure to stick your error somewhere vaguely up in this area. And that's it. That is how you're going to do the assignment. Yep, that's it.